Math 113 lesson 10.2 is about the hyperbola. Now if you watch other videos that you find online, you may hear some people pronounce that as the hyperbola. I prefer to call it the hyperbola. So it's the same thing if you hear it pronounced differently. Okay, a hyperbola does not at all look like the circle or the ellipse. It's not circular at all. Really what it would be like is if we took a circle and we cut it in half and then we flipped the pieces outward. So a hyperbola could look like this. That is one hyperbola. Imagine if you took a circle, you cut it in half, and then you flipped the pieces the other direction. This is what it would look like. So that's one hyperbola. Your hyperbola could look like this. All right, so two different hyperbolas here. These are not the same thing, but one hyperbola is two curves. All right, so there are some important parts of our hyperbola that we need to talk about. One of those is a part that looks a line that joins those 2 points. All right, this point in the middle is still considered our center. These two red points are considered a vertex. Each one is a vertex. So the line that joins our vertices, it's no longer called a major axis like in an ellipse. It's called the transverse axis. The transverse axis. So if we draw that over here in this one, our center is this point here again in the middle. These 2 points would be considered our vertices, so each one is a vertex. And then the line that connects those is called the transverse axis. Okay, so the transverse axis connects the vertices of a hyperbola and it goes through the center. So that's a super important part of those. Another thing that is important on our hyperbola would be a foci. Okay, we do still have foci in our hyperbola. Our foci this time, imagine that our line, our transverse axis, were extended. Okay, my foci, I'll do those in blue. My foci are on this line. Right, away from the center. Okay, this time it's going to be away from the center. So inside the curves, think of it like that, inside the curves is where your foci will be located. So this transverse axis, if I extend it out, okay, it's just a line. If I extend it on out, my foci lies somewhere inside the curve, okay? So we still have foci. The foci are C units from the center. Okay, that has not changed. That was the same way on an ellipse. The vertices are A units or spaces, whichever word you prefer to use, from the center. That has not changed. That was true in an ellipse. So the value of A and the value of C, the actual words, represent exactly the same thing. Now both the foci and the vertices are located on the transverse axis. Okay, both of these are on the transverse axis. Right? A, B, and C do have a relationship again. C squared is equal to A squared plus B squared. It is a different relationship this time. C squared equals A squared plus B squared. All right? So let's look at what our equations will look like. And slide this up so I have room to write them. The standard form of our equations. They start a lot like the ellipse. Let's see if you can tell the difference of this equation and an ellipse equation. The biggest difference is that big minus in the middle. All right, that big minus in the middle. Now this time we don't have a major axis, but we do have that transverse axis. We have a horizontal transverse axis. Remember how we decided if the major axis was horizontal before? We looked at how A was up under the X value. Well, the same thing here. If A is up under the X value, your transverse axis is horizontal. So this particular ellipse, I'm sorry, this is a hyperbola. This particular hyperbola would look like this, so that its transverse axis is horizontal. Okay? So our other equation, okay, now this one is slightly different than what we did for an ellipse. So make sure you have these equations beside you. This time, I didn't move that a squared. It stays where it belongs, there. And notice it is up under the y. That is different. Still have the minus. So these equations are not identical. So don't look at your ellipse equations and go, oh, it's exactly the same thing with a minus in the middle. That is not true. Okay, that is not true. You're going to mess up if that's how you do it. So make sure you have these equations beside you. Okay, on this one we have a vertical transverse axis. And if we look at our A value, it's up under the Y this time. So that's why our transverse axis is going to be a vertical line. Right? So making sure we have the correct equation is going to be super important. Super important. And all hyperbolas have something that ellipses do not have. All hyperbolas have, whoops, didn't mean to draw that line. All hyperbolas have asymptotes. An asymptote is a line that the graph approaches, but it doesn't actually touch it. Okay, it doesn't actually cross it. The equations for our asymptotes depend on if it is a vertical or a horizontal. So for all of our horizontal asymptotes, we end up with y, y minus h. Okay, these are our asymptotes. Is equal to plus or minus b over a times x minus h. That's just the point slope form of a line. I'm sorry, this should be a k, not an h. Y minus k is equal to plus or minus b over a times x minus h. If you have a vertical transverse axis, your equation for your asymptotes will be y minus k is equal to plus or minus a over b times x minus h. So your asymptotes depend on, the only thing that changes is your slope. Okay, your asymptotes have different slopes. if it is horizontal or it is vertical, so it will matter. So having all this information beside you as we get ready to do a hyperbola. All right. Let's start with, I only want you to find the vertices and locate the foci on this particular one. I'm actually going to give you two of them for each hyperbola. All right, so our first hyperbola and our second hyperbola. All right, so two entirely different hyperbolas. We're going to find the vertices and locate the foci. You are not asked to graph these. Okay. So just like in an ellipse, a squared is always greater than b squared. So I know that 25 is my a squared and 16 is my b squared. All right, I know I have that much. That means that a is 5 and b is 4, right? I need to know the c value since I'm asked to find the foci. So the c value is a squared minus b squared. I'm sorry, plus, this one is a hyperbola, so it is a different formula. A squared plus b squared. So we get 41. Take the square root, and I get square root of 41. All right, so we were asked to find our vertices. Well, even though I wasn't asked to find it, I need to know what my center is so that I can do my vertices. So if I look at my equation, it appears that there's no h and k, so that means the center is the origin. All right, vertices. Now before I can answer this, I need to know if my transverse axis is horizontal or if it is vertical. In this case, the a value is up under the x. That means it has a horizontal transverse axis. Okay, so it looks like this. All right, so I know for sure that's what's going on because of where the a is located, the a squared is located. Now that helps me know where my vertices are because my vertices, the distance from the center to the vertex is a, right? So that's left and right. So I go from my center and I go to the left a spaces and I go to the right a spaces. So my vertices would be negative 5, 0 and 5, 0. My foci are c spaces and they are also on that transverse axis. Okay, those are my foci. The first ones I did were our vertices. And they are c spaces from the center. So we have our center and we go square root of 41 to the right. So square root of 41, 0. And square root of 41 to the left, which would be negative square root of 41, 0. So we have now found our vertices and our foci. All right, let's do question B. It asks us to do the same thing. Asks us to find our vertices and our foci. We're going to start the same way. I know that 25 has to be a squared and b squared is 16. So that makes a 5 and b 4. I need to know c squared. So I say 25 plus 16. Again, I get 41. So c is the square root of 41. It didn't ask for my center, but I do need to know it before I can answer my vertices and my foci. When I look at my equation, it appears that I do not have an h and k, so they are 0, 0. before I can answer vertices, I need to look at where a squared is located. It is under the y squared. So this has a vertical transverse axis. So it's going to look something like this. All right, so this would be a vertex, and then our center will be in there. All right, so my vertices, this time we're going to go up and down to get to my vertices. So I take my center value, which is 0, 0, my ordered pair, and I go a spaces up, okay? From the center to the first vertex, I go a spaces up. So that would be 0, 5. The other one I go down 5, so 0, negative 5. Notice the difference in the vertices we found on answer B and the vertices we found on answer A. They are completely different, even though they do use the same value 5. They are completely different spots. So if you get this wrong, you get nothing for it, because it means your hyperbola is not even going the right direction. All right, your foci are also on this transverse axis. Imagine it keeps going. And so our foci are somewhere on here. And they are C spaces from the center. All right? So I'm going up and down. So the x value is not changing on my center. And I'm going to go square root of 41 up, or I'm going to go square root of 41 down from the original center value. So those are my vertices and my foci. Didn't even ask you anything about an asymptote here because we didn't have to technically graph it. All right. It's going to take some practice, especially if you have never before seen ellipses and hyperbolas. Let's change up the question a little bit. Find the standard form of the hyperbola. Whose foci are 0, negative 5, and 0, 5. And vertices are 0, negative 3, and 0, 3. So we are asked to find the equation, to write the equation, find the standard form. All right, so I'm going to first start by just kind of sketching on a graph what they gave me. Negative 5 and 0, 5. Those are my foci. 0, negative 3 and 0, 3. Those are my vertices. Now remember, your foci and your vertices are on the transverse axis. So I definitely have a vertical transverse axis. All right, once I just drew it, I could see that. All right, so since I have a vertical transverse axis, then I know my equation is going to look like this. All right, I know for sure because I have a vertical transverse axis, the a squared has to be up under the y. All right, so I've got to know my center. Well, remember your center is midway between your vertices, so your center is going to be the origin, 0, 0. So y minus 0 and x minus 0. Now I need to know my a squared and my b squared. Okay, so let's look at the diagram up here. The distance from the center to a vertex is a. Okay, so we know that a is 3. which means a squared is 9. All right, so 9 is going to go right here. I know that the distance from the center to the focus is C. So my C value is 5, which makes C squared 25. Now that does not go up under the other fraction. B squared goes under there. I need to find B squared by saying C squared is equal to A squared plus B squared. So 25 is equal to 9 plus B squared. Take the square root of both sides, and I get B is 4, which makes B squared 16. That's what we were looking for, is actually B squared. Because B squared goes under here, 16. All right, now I don't want to leave that minus 0 because I can actually subtract. My math lab would say it wasn't simplified. So this would be our equation. Y squared over 9 minus x squared over 16 equals 1. All right, so all it asked for was the equation. We were still not asked to graph it. When we are asked to graph it, we are also going to be asked something about the asymptotes. So let's do one where we have to worry about asymptotes. All right, so we're going to graph this, and we're going to make sure we identify the foci and the equations of the asymptotes. All right, and we're going to graph it. We are asked to graph this one. Okay, let's start with our A value and our B value. All right, I know that A squared is 4, which makes A 2. I know that B squared is 1, which makes B 1. I don't know if you guys can see my stuff disappearing. That is a little frustrating. Alright. Now I need to decide, is this a horizontal or a vertical transverse axis? It is a horizontal transverse axis, which says to me that it's going to look like this. Now, this is not my actual graph. This is just a sketch for me to remember what this thing is going to look like. All right. Next thing I need to know is my C value. So A squared plus B squared. So my C value is the square root of 5. Before I try to graph, I'm going to talk about the center, my vertices, and my foci. Okay, so my center, this time there is an H and K up there. My H, remember you take the opposite sign. My H is positive 3 and my Y is positive 1. My vertices, since this is horizontal, okay, since it's horizontal, my vertices, remember they are A spaces from the center. So I am going to add my A value, which is 2. I am going to add it to the 3 because we're going left and right. right? So I'm going to say 3 minus 2 gives me 1, and 3 plus 2 gives me 5. Those are my 2 vertices. Now if we need to graph that as we go so you can visualize, that's fine. I'll draw my graph in purple. Okay, my center is 1, 2, 3, 1. There's my center. My vertices are A spaces from the center, left and right. So 2 spaces to the right, 2 spaces to the left. So hopefully that makes a little bit more sense if you were a little confused. All right, there's my vertices. Next thing I want to talk about are my foci. Again, they are on that transverse axis, so they are left and right. C spaces. So C spaces from the center are my foci. So I am going to say 3 plus the square root of 5, 1, and 3 minus the square root of 5, 1. Those are those 2 ordered pairs. Okay, this 3 plus the square root of 5 is about 5.2. The 3 minus the square root of 5 is about 0.76. Just so you can kind of know where to put that on your graph. I'm going to go back to my purple. All right, so 5.2 would be really close to my vertex. So I'm going to move that little V over a little bit. So here would be my foci. And then this other foci would be really close right here. It says 0.76, probably even closer than what I drew it. All right, so I've got those. Now, I can't draw my curves yet. I know the direction that my curves go, but I don't know how fat my curves are. So that's where the asymptotes help us out. So the next thing we're going to do is find our asymptotes. So we've graphed our center, our vertices, and our foci. Now we are going to worry about those asymptotes. Now we know that ours has a horizontal transverse axis, right? So that gives us this equation because it is a horizontal transverse axis. I remember I gave you those equations based on whether it was a horizontal or a vertical. That's how we knew our asymptotes equations. The slope is really the only thing that changes. So since this one's horizontal, our slope is B over A. Okay, so now let's plug everything in where it goes. Our K value is 1, plus or minus. Our B value, okay, remember we found our B value was 1, our A value was 2, and our H value is 3. All right, so there's our asymptotes. Now, that's just 2 lines. All right, I'm going to simplify a little bit. So I end up with 2 equations. I have positive 1/2 times x minus 3, and then I have whole nother equation that says negative 1/2 times x minus 3. 2 separate equations, all right? That's what plus or minus means. All right, so I'm going to solve for y because that's how I like to graph lines. So 3 over 2 plus 1 whole, which would be 2 over 2, would be minus 1/2. For this other one, distribute that half. I get negative 1/2 x plus 3/2. Add 1. So this time I get y is negative 1/2 x plus the 5 over 2. Okay. All All right, so now I've got to use those two equations on my graph. So let me write them up here so when I pull this back up, we can see what we're looking at for our asymptotes. All right, so I'm going to slide back down so we can look at our graph. I'm going to graph my asymptotes in yellow. Okay, so my first asymptote, I'm going to graph this one right here first. All right, my y-intercept is negative 1/2, right there. And I have a slope of 1/2, so I'll go up 1 to the right 2. Up 1 to the right 2. Up 1 to the right 2, and keep going. So, whoops. So there's that first asymptote. All right, so let's graph the other one. My y-intercept is 5/2, which is 2.5. So 2.5 would be about right here. And my slope is negative 1/2, so I'll go down 1 to the right 2. Down 1 to the right 2. So this line, something like this. Both asymptotes go through the center. All right. Now what this does for me is it shows me how fat my curve is going to be. Now I'm ready to draw my curve because my curve goes through the vertex alongside the asymptotes. So through the vertex alongside the asymptotes, never crosses the asymptotes. That's the whole point in having those asymptotes, is it shows me how wide or how narrow those curves are going to be. And there we are. That would be our graph. And we found our foci, and we found our equations of our asymptotes. And those were 2 questions that we had. All right, this is definitely going to take some practice. Let me know if you have any questions.